Alright, so in this problem, I have 4 to the power of x is equal to 8. So I want to find the value of x. For my solution, first start with 4 to the power of x is equal to 8. And 4, this is the same thing as 2 to the power of 2. And 8, this is the same thing as 2 to the power of 3. So now if I replace 4 with 2 to the power of 2, and if I replace 8 with 2 to the power of 3, I get 2 to the power of 2 to the power of x is equal to 2 to the power of 3. Now, if I have something in the form a to the power of m to the power of n, this is simply equal to a to the power of m times n. So 2 to the power of 2 to the power of x, that's going to equal 2 to the power of 2 times x, which is simply 2x, which is equal to 2 to the power of 3. Now, if I have something in the form a to the power of m is equal to a to the power of n, then this means that m is equal to n. So in this case, 2x is equal to 3. So I have 2x is equal to 3, so I'm simply going to divide both sides by 2. These two cancel out, and I'll be left with x is equal to 3 over 2. So this is my answer. Now, there's actually a second method of solving this problem. So again, I first start with 4 to the power of x is equal to 8. But this time, I'm going to take the log on both sides. So now I have log 4 to the power of x is equal to log 8. Now, if I have something in the form log a to the power of b, I can actually move this exponent b to the front. So this is going to equal b times log a. So in this case, for log 4 to the power of x, I can move x to the front. So that's going to equal x times log 4, which is equal to log 8. Now I can simply divide both sides by log 4. These two cancel out, and I'll be left with x is equal to log 8 over log 4. Now, remember 8, that's equal to 2 to the power of 3, and 4 is equal to 2 to the power of 2. So now I have log 2 to the power of 3 over log 2 to the power of 2. Now I can move these exponents to the front. So now I have x is equal to 3 times log 2 over 2 times log 2. These two log 2's can cancel out, so I'll simply be left with x is equal to 3 over 2. So this is my answer. Alright, so for this problem, I have x is equal to x over 2. So I want to find the value of x here. So for my solution, first start with x is equal to x over 2. Now, I'm actually going to subtract x over 2 on both sides. So then, these two x over 2's cancel out, and now I'll be left with x minus x over 2 is equal to 0. Now, I'm going to multiply both sides by 2. So now I have x minus x over 2 times 2 is equal to 2 times 0. So for 2 times x minus x over 2, I'm simply going to distribute the 2 to all terms in my parentheses here. So first off, 2 times x, that's simply equal to 2x, and 2 times negative x over 2, the 2 simply cancel out, so all I'll be left with is negative x. And this is equal to 2 times 0, which is simply equal to 0. So I have 2x minus x is equal to 0. Now 2x minus x, that's simply equal to x. So I have x is equal to 0. So x equals 0 is my solution. Now I actually have a second method of solving this problem. So again, I first start off with x is equal to x over 2. And now this time, instead of subtracting x over 2 on both sides, I'm actually going to multiply 2 on both sides. So I have 2 times x is equal to x over 2 times 2. Well, 2 times x is simply equal to 2x, and x over 2 times 2, these two 2's cancel out, so I'll simply be left with x. So I have 2x is equal to x. Now, I'm going to subtract x on both sides. These two cancel out, and I'll be left with 2x minus x, which is x, is equal to, on my right-hand side, I'll have 0. So x equals 0 again. So now to check, I have x is equal to x over 2. We know that x equals 0. So I have 0 is equal to 0 over 2. 0 divided by 2 is 0. So I have 0 equals 0. And because this is right, my solution is right. Alright guys, so in this problem, I have 2 to the power of 20 minus 4. So I'm going to first start by rewriting 2 to the power of 20 as 2 to the power of 10 times 2. So I have 2 to the power of 10 times 2 minus 4. Now, if I have something in the form a to the power of m times n, this is equal to a to the power of m to the power of n. So 2 to the power of 10 times 2, we can rewrite as 2 to the power of 10 to the power of 2. Now I have this minus 4. 2 to the power of 10, that's equal to 1024. So now I have 1024 to the power of 2 minus 4. And 1024 I can rewrite as 1000 plus 24. So now I have 1000 plus 24 to the power of 2 minus 4. Now if I have something in the form a plus b squared, this is equal to a squared plus 2ab plus b squared. In this case, a is equal to 1000 and b is equal to 24. So I have 1000 squared plus 2 times 1000 times 24 plus 24 squared. And then I have my minus 4 at the end. Now 1000 squared is equal to 1 million. 2 times 1000 is 2000. 2000 times 24 is going to be 48,000. Now 24 squared, that's going to equal 576. So I have 576 minus 4. And 576 minus 4 is 572. So I have 1 million plus 48,000 plus 572. And this is equal to 1,048,572. So this is my answer. Alright, so in this video, I'm going to be solving the problem 100 to the power of x is equal to 10 to the power of x plus 1 to the power of x. So, to solve this, what I'm first going to do is rewrite 100 to the power of x as 10 squared to the power of x. So now this is equal to 10 to the power of x plus 1 to the power of x. Now, if I have something in the form a to the power of m to the power of n, this is equal to a to the power of n to the power of m. So 10 to the power of 2 to the power of x is equal to 10 to the power of x to the power of 2. So now I have 10 to the power of x to the power of 2 is equal to 10 to the power of x plus 1 to the power of x. Now, if I have something in the form, 1 to the power of any number is just going to be 1. So we can just get rid of this x as an exponent because it won't really change anything. So now I have 10 to the power of x squared is equal to 10 to the power of x plus 1. And now from here, I'm going to let 10 to the power of x equal to the variable m. So now I have m squared is equal to m plus 1. And this turns into m squared minus m minus 1 is equal to 0. Now I'm going to use the quadratic formula to solve this. So the quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. So in this case, a is 1, b is negative 1, and c is negative 1. So I get m is equal to negative of negative 1 plus or minus the square root of negative 1 squared minus 4a which is 1 times c, which is negative 1, all over 2a, so 2 times 1. And this turns into positive 1 plus or minus the square root of plus 4 over 2, which is equal to 1 plus or minus the square root of 5 over 2. So this is the value of m. And to be precise, the two values of m are 1 plus the square root of 5 over 2 and 1 minus the square root of 5 over 2. Now, remember how we let m equal 10 to the power of x? So 10 to the power of x is equal to 1 plus the square root of 5 over 2, and 10 to the power of x is also equal to 1 minus the square root of 5 over 2. So for my second equation over here, 10 to the power of x is equal to 1 minus the square root of 5 over 2. Well, 1 minus the square root of 5 over 2 is a negative number. And you can't take the power of a positive number and make it equal negative, meaning there's no solution to this equation. So we are only left with 10 to the power of x is equal to 1 plus the square root of 5 over 2. And to solve this, I'm going to take the log on both sides. So I get log 10 to the power of x is equal to log 1 plus the square root of 5 over 2. And if I have something in the form log a to the power of b, I can move the exponent b to the front, so this turns into b times log a. So now I have log 10 to the power of x, which I can move x to the front, so I get x times log 10 is equal to log of 1 plus the square root of 5 over 2. And now I'm going to divide both sides by log 10. So then these two cancel out, and I get x is equal to log of 1 plus the square root of 5 over 2 over log 10. And log 10, if you guys already know, is equal to 1. So this turns into log of 1 plus the square root of 5 over 2 over 1, which is the same thing as log of 1 plus the square root of 5 over 2. There's no need to include the over 1 because anything over 1 is itself. So this is my solution to this equation.